Let us try this example. Given the functions of y is this, you are asked to determine the maximum or minimum point of the functions. To solve this, first you need to differentiate the y functions, which you obtain this. Next, you determine the turning point by equating the dy d theta equals to 0. Substitute 0 into the functions of dy d theta. Solve the functions with the existence of the log, and you will get theta equals to negative 1.3x63. You need to determine the point. Now we have the theta here. Your next step is to determine the y. Substitute the theta obtained into the y functions, and you obtain y equals to negative 1.5452. This will be your turning point. Next, you need to determine whether it is a maximum or a minimum point. From the functions of dy d theta, you have to differentiate to d squared y per d theta squared. This will give you e power of negative theta. Use the theta of the turning point, substitute into the functions. You will get the value as a positive. With that, you know that this is going to be a minimum point. Now let us try another example. The function now is this. You are asked to determine the coordinate of the maximum and minimum point value of the graph. To solve this, first you need to differentiate the y functions. This will give you this dy dx functions. Now you need to identify the turning points by equating dy dx equals to 0. Substitute 0 into the functions of dy dx. You will get x in the power of 2, which after factorizations, you know that it is equals to negative 2 and 3. That means the turning point happens when the x is equals to negative 3 and equals to 3. Now you need to determine the coordinate of the turning point. Substitute x equals to negative 2 and equals to 3 into the functions of y. This will give you y equals to 9 and y equals to negative 11, 5/6. From there, you will know that the coordinates of the turning point will be negative 2, 9 and 3, negative 11, 5/6. Next, you will need to determine the maximum and the minimum point. From the functions of dy dx here, you will have to differentiate another time to obtain d squared y per dx squared, which is given here. Substitute the point x equals to 2 and x equals to 3 into the d squared y per dx squared. You will obtain negative value and the positive value. Negative value means it is a maximum point, and positive value means it is a minimum point. With that, you know that the point negative 2, 9 will be the maximum point, and the point 3, negative 11, 5/6, it will be a minimum point. If you actually plot this curve, the curve will look something like this. The maximum point will occur when the x is equals to negative 2 and equals to 3 as obtained in the previous calculations. The maximum point occurs at negative 2, 9 and minimum point occurs at 3, negative 11, 5/6.